Okay, so welcome back. Now, over a month ago, I posted the first video in this series, and the goal of this series is to give those who think they are skilled software developers a challenge. And the goal of the challenge was to show how what many people believe in the science, engineering, software world is actually incorrect. And they tend to believe that as long as I know the tools at my disposal and how to use them, then I can solve any problem. In the software world, people think, well, as long as I know a certain language or I know how to do a for loop, then I can solve science, engineering, technical problems. And the goal here was to show how totally incorrect that is most of the time. And what we did is we gave the challenge of trying to figure out an algorithm that would do what you see here. And I've got a C# Visual Studio Windows Forms application that is using some of the algorithm that we have developed so far. And all it's doing is it's taking these pairs of numbers separated by commas and determining how it can draw this diagram that represents this input data. And as we talked about before, this represents an actual real-world electric power system where we've got buses in blue and lines in red. And the goal here was to show that it's really a lot of work and skill to be able to take that problem and figure out how to design a solution. And once you've got the solution designed, once you figure out the algorithm, then using the tools is the easy part. So what we're going to do in this video is we're going to get down to the actual algorithm that we have developed so far, and that's being used for the most part in this C# application. So one technique I like to use when trying to figure out a fairly complex algorithm is to do it visually, graphically. One of the problems when you're thinking in your head, you tend to forget about things or overlook important aspects of the algorithm. And when you draw it out, it's a lot easier to keep in mind all of the pertinent aspects. So what we're going to do is we're going to start out with our grid here. We've got some lanes and columns as we talked about previously. And I've placed two buses, bus 5 and bus 1. And we have a line between 5 and 1. We also have, you can see down here, a line between 1 and 2. So our next step is to place bus 2. So now the first thing we need to think about is, as you can see here, this bus 2 is taking up 2 positions. It's nice when you're starting out, figuring out where to place the bus, to know exactly how many positions it's going to occupy, how many positions it's going to require. So it's nice to have the first step to be try to get an idea of how long this bus is going to be, because it's going to affect how you place it. So for example, if we want to place it down in this last lane, we can't because it's going to go past the last lane. So we're limited to where we can place it. So it's really important. And the first step is to figure out the length of the bus. So now that we know that it's a 2-position bus, let's think about the steps we would need to figure out where to place it. Well, we know we can place it here. We've got a line from 1 to 2, so it's nice to place it in the same lane as number 1. So we could place it here, we could place it here, or we could place it here. Anywhere that you're in the same lane. Now you can't place it here because that would put it in the same column and it would extend that bus and it would be confusing, so you can't do that. And as we said before, you can't put it in the last lane because it would go past the length of the lanes. So we'd probably think about putting it either here, here, or here. So these are the most obvious choices of where to place it. However, there's other places we could place it. For example, we could decide that this bus number 1 is actually requiring 2 positions, and that means you've got more choices on where to place it. So for example, we can now place it down here. Before we could place it here, now you can place it down here, and you can draw a line from bus 1 to bus 2. Likewise, we could place it here or here. So one of the points to consider is, are we going to allow ourselves to increase the length of the bus in order to give us more positions to place it? So that's a consideration. So now let's say our bus 1 is in column 2. Here's column 0, 1, 2, and it's taking up 2 positions. We could arbitrarily decide to move it out here, which means that now we can place our bus 2 not only in all of these positions, but we could also place it over here and run a line from bus 1 to 2. So again, that's another option that we can decide if we want to go there. Again, we can place it down here, However, we would have to further extend that bus. So here's another alternative for placing that bus too. So from that, we realize that the first step we're going to need to take is figure out, if we're going to place a bus on the grid, figure out how many positions it will require, how many positions will it occupy, otherwise, what's the length of the bus. So that should be pretty straightforward, right? Well, let's look at this grid that we talked about in the previous videos. You can see here this bus number 1 has 2 lines, one coming in, one going out. So 2 lines on the bus requires only 1 position. However, this bus number 2 has 2 lines, but it requires 2 positions. So knowing how many positions a bus is going to require is kind of tough, right? It depends on the final configuration. So one approach is to, for example, take the worst case and decide that, if a bus has only 1 line terminating on it, use 1 position. If it has 2 lines, use 2 positions, 3 lines, 3 positions, and so on, and draw out your diagram based on that. And then you would have to do kind of an optimizing step that went through and took that configuration and said, well, do we really need all of these positions? Can we optimize this diagram and get it down so we don't have too many positions on each bus? So I think no matter what algorithm you use to determine the length of the bus or how many positions it's going to occupy, at some point you're going to have to do some sort of optimization, if nothing else, for the determination of the ultimate numbers of lanes and columns in your diagram, because you really don't know that either until you've done the placement, and then you can go back and say, well, I don't need all of these columns and lanes. So I think we're going to apply an algorithm and then have a separate step that goes back and optimizes. And I think the algorithm we can use is, if a bus has 1 or 2 lines terminating on it, we'll start with 1 position. If it has, like this bus 3, if it has 3 lines or 4 lines, we'll use 2 positions, and so on. If it's 4 lines or 5 lines, you use 3 positions. And then we're going to have an algorithm to do the optimization later on to determine the columns, the lanes, and whether we can reduce the number of positions for each bus. So at this point, we've looked at the basic data structures we're going to need. We talked about grids and columns, positions, lanes, and blocks. And we've also talked about some of the limitations we're going to have and some of the requirements for placing buses. And at this point, we can now get deeper into the algorithm so that we can start writing our code. So we initially talked about a grid with columns, positions, lanes, and blocks, because we're going to need all that data in order to define where we place the lines and the buses. And we're also going to need to have some data storage for the graphical aspect of this. Where do we place the buses? Where do we draw them in our bitmap? So as you can imagine, we're going to have a grid class that's going to have columns, positions, lanes, and blocks. And each of those components can be a class that's going to have data, both graphical data and like occupied, which positions are occupied and that kind of thing. So once we've got the grid initialized, what we can then do is figure out how to place buses. And we said before, we're going to start with the left bus that we're going to define as the one with the most lines coming out of it. And once we've got that, we can figure out from that bus what are all the buses we have to place, all of the 2 buses. As we said before, for each 2 bus, we're going to have to determine the number of positions required. And our decision was, for now, 1 or 2 lines will be 1 position, 3 or 4 lines will be 2 positions, 5 or 6 lines will be 3 positions, and so on. So once we've got that, now what we have to do is we have to check what positions are available in one of the lanes or positions occupied by the from bus. So for example, here's our from bus as we start out, and we're going to place number 1. We look at all the available and everything's available. And then this number 1 becomes our from bus. If we have to place the number 2 bus, that becomes our 2 bus. And we're going to have to iterate through all of the buses. We also looked at the possible need to check available positions to the left of your bus. But what we're going to do is we're just going to go from left to right and ignore any opportunities to put buses to the left of the from bus. All right, so we're going to flow from left to right. And then what we have to do is step through each column to the right and each position in that column to see if available. So each of these columns, positions, lanes, and blocks is going to have a property that tells us if it's occupied. We're also going to have to check the lanes and positions above and below to see if they're available. And then once we've got the bus placed, we're going to have to make all of the to buses from buses and repeat. We're going to have to iterate. So as we said, here's our from bus, here's our to bus, we place it, and then this becomes our from bus, and then we place all of the to buses. And then we're going to have to iterate through and get all the buses. Once we're done, we can review whatever layout we came up with and optimize it as we talked about before. So as you can imagine, we're going to have a grid class, and each grid class is going to have a list of column class objects and a list of lane class objects. And each column class is going to have a list of position class objects. And each position object is going to have an occupied property. Same with the lane class, it's going to have a list of block class objects with an occupied property. So then we can figure out for each column, position, lane, and block which one is occupied for buses and lines. Now when we look at the column objects, you're going to have a vertical column here, and each one contains positions. So you can imagine that these columns and positions, the entire array of columns and positions would look like a two-dimensional array with columns and positions. So you could specify, like, here's column 0, 1, 2, 3. So column 3, position 2 is down here, and we can access that and check whether it's occupied. So that's going to be the basic layout and structure of our data. And here is the C# Visual Studio Windows Forms application we're going to be using. Basically, we've got some documents to do, some properties that we'll get into later. I've specified columns, lanes, and margin for the image. But basically, I've got a bunch of methods that are going to go through and do this. And we'll talk about these in a future video. We're going to initialize the bitmap that we're going to draw on. We're going to initialize the grid, which we specify how many columns, lanes, and we're going to have to get a list of buses from this input line data. And then to place the left-hand bus, we're going to get the bus with the most lines. And then we're going to go through, use that left-hand bus as the from bus, figure out all of the to buses, and place those buses, place the lines. And once those are all placed, we can optimize the diagram, and then we can draw the lines and draw the buses, and then draw the bus numbers. So I've specifically made this as two separate procedures, placing the lines and buses and then drawing them, because we want to have them placed, but we don't want to do it final drawing. We want to optimize first and then draw them. And then we've got a bunch of methods that are going to be doing all of this, and some helper methods that are going to be included. And you can see we've got a bunch of helper methods here that we'll go through in the future. But that's about it for the basic layout of our application. So that's about it for this one. In the next video, we're going to dig into the C# Visual Studio Windows Forms code that we use to develop this and show you how we implement the algorithm we've been talking about. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.